Going. All right, so we finished 6.3, right? I'm remembering right? 6.3 was due today, right? We finished 6.2 and 6.3. Okay, so trigonometry. Basically, 6.4 is about graphing. I don't know what you remember about graphing. Let's take a look at this one. So they're giving us this graph here, and they're saying, for what numbers is the graph of y equals cosine of x decreasing? Remember, decreasing means going down from right to left to right. So I would just do like the roller coaster thing, you know, you're on a roller coaster and you're cruising, right? You'd be going up in this section, then you're at the top, and then it would be this section when you're going down. So the cosine would be decreasing all in that zone, huh? That's the decreasing. So that's from x is 0 to x is pi, isn't it? So from 0 to pi, the cosine is decreasing. Good. Remember, cosine's the one that starts high in the middle, huh? That's cosine. What is sine? What's the graph of sine? Yeah, that sine starts in the middle, goes high, goes low, comes back to the middle. Remember, sine does that. So cosine's the same as sine. It's just phase shifted. It just starts high, finishes high. It's just off a 90-degree phase shift. That's why we have the names cosine and cotangent and cosecant. I don't know if you ever thought about why do we have these three co-functions? What does co mean? Co in general means with in the English language, but specifically in the math world, it comes from the word complement, which complementary angles add, if you remember from geometry, to equal 90 degrees. They're like a 60 and a 30, or they're two angles that add to be 90. So when we call the sine and the cosine, we mean it's the same thing as the sine, it's just shifted 90 degrees. That's what we're doing with the co. Cosecant is the same as the secant, it's just shifted 90 degrees. Cotangent is the same as the tangent. The graph has just been shifted, slid right or left, 90 degrees. That's all that is, anyway. So cosine and sine are really the same exact graph. It's just been moved 90 degrees, right? If I did the rest of the cosine, it would be over here like this. If you start here, it looks just like the sine, doesn't it? See, and that's back 90 degrees. It's 90 degrees back. If you just back up 90 degrees, then you have the sine. So cosine and sine are the same. They're just 90 degrees shifted. Okay, So where does the sine of x equal 1? Remember, whenever you have a function, sine is a function. It's like f of x equals 1. It's kind of what they're saying, except it's sine of x, right? You want to think of trig, sine, cosine, tangent, they're functions, natural log, all that kind of, those are all functions, right? You plug stuff in, get stuff out. What you put in is x, what you get out is always y. That goes for all functions. G of x, h of x, sine of x, cosine, tangent, natural log, e to the x, all the functions that we use. What you plug in is x, what comes out is y. That's by common agreement. They just said, hey, when we take these functions and put them on graphs, let's make the thing we plug in be the x-axis, and the answers that come out, we'll put those on the y-axis. That was just by common agreement. Okay. So what? Why am I saying all that? Well, I'm saying this question then is saying, where's y1? If you know that, then you know this question is basically saying, look at this graph. Where is the y value 1? Right there. That dot right there, huh? So what is x when y is 1? X is pi over 2. Done. Makes sense. The answer is x is pi over 2 when y is 1. That's all they're asking. Good? I'll keep moving. All right. Do you know the amplitude? What's the amplitude of y equals 3 sine x? Yeah, the amplitude's that number in the front, huh? It's 3. And by the way, even if they give you negative 3, well, I said the amplitude's A. That was real smart. Amplitude's 3. Yeah, even if they put a negative 3, by the way, you still just say positive 3 for the amplitude. They always want you to, it's kind of like distances, you know what I mean? It's just our common language. It's not really a math thing as much as it's just common language. When we talk about distance, we never give a negative answer, do we? Right? When I say, hey, I'm going to go down to L.A., I don't say it's negative 250 miles because it's south. We just don't talk that way. We just distances are always given as positive. Same thing as amplitude. They just always want the positive, even if the number in front is negative. So I wouldn't care in a test if you said -3. It's just silly. But anyway, Math Excel will care, and they'll mark you wrong. So it's +3. Anyway, ours was +3 anyway, so it wasn't an issue. Now, what's the period? That's the second question they're going to ask you. What's the period? Anybody know the period for the sine graph? 2 pi, yeah. That's how long he repeats his cycle, right? So sine starts off, boom, from 0 to 2 pi, he does a cycle. Then he just keeps redoing that. There's another cycle at up to 4 pi, and then he does another one at 6 pi. You know, every 2 pi, and even going back, every 2 pi, he just keeps doing a cycle. So the cycle for sine is 2 pi. Now, that's for regular sine, or 3 sine. It's the same thing for this one. Now, if they start messing with the x, if they give you something like sine of 7x or something, now that's going to change the cycle if you put a number in there with it. Now, this 3 here doesn't change the cycle at all because that's not an x effector. It's in the front, so it's a y effector. It has a vertical stretching effect, doesn't it? It makes the sine go up 3 and down 3. Instead of up 1 and down 1. We'll get to that. I'll give you all the details in a minute. I'm just kind of giving you a preview of basically what we're going to do in detail in a second. So numbers in the front, stretch it vertically. Numbers in there with x have a horizontal kind of effect. Thus, they will affect the period, the cycle. And I'll give you a formula for that in just a second. I just want to kind of give you that idea right now. So y equals 6 cosine pi x, okay? Now, first off, the amplitude. What's the amplitude? That's just the 6. No big deal there. Now, what's the period? Well, let me give you the formula now. The period for cosine and sine is 2 pi over k, where k is whatever is next to x. Yeah, so whatever's next to x, in this case, our k is pi, isn't it? So the period is 2 pi over k, which is pi, cancel 2. The period is a straight 2, not a 2 pi, but a straight 2 for this one. That formula is super important. We'll use it a whole bunch in this section, virtually every problem. We'll use it to figure out our period. It's not on Thursday's test. It's not even due for homework till next Tuesday. It's on the final, though. Final is in 2 weeks from today. Yeah? 16th. Exactly 2 weeks from today is our final. So this section, as well as a couple others, will be on the final along with everything on that. Good there? Questions on that? Okay, so what's the amplitude? Yeah, 3/5. It's just, again, that number in the front is always the amplitude. Now, can you figure out the period on this one? Let me give you a second. 2 pi over k, right? Period's always 2 pi over k. K is the number or the whatever is in front of x. So it's that whole negative 2 pi over 5 thing. That whole thing's the k. Can you plug that in for k and then kind of flip the fraction to the top, you know, and clean it up a little bit there? On that. 2 pi over k. K is negative 2 pi over 5. Like that. You know what? You're catching your teacher without being sure here. I think period's always positive as well. I hate those I think those things are dumb. Like, who cares whether you call it positive or negative? It's the cycle. But I think they want always, on a test, I would not care. Give it to me negative or positive, you get full credit, because it's really kind of dumb to even think about whether it's negative or positive. It's a width of a cycle. It's a repetition. So I think they only want positive answers on Math Excel. I wouldn't care on a test either way. It's unimportant. I just care about concepts more. But anyway, I'll check it out. I'll enter the answer here with you. I think they want only positive for both period and cycle. I mean, that was the same thing, wasn't it? Period and amplitude. So the 2 pi's cancel. Negative 5, but I think they want positive 5 only. Positive for period and amplitude. So I say now, I'll go check. If I'm wrong, I'll come back and change that. So I think they want positive 5 only. On a test, I wouldn't care. Is that okay? Can I go check? You guys got that down? I'll go check. So here we go. All right, so let me help you all with this. This is where I really want to be helpful. I want to give you a plan. I think I can make it easy for you because there's not that much to it, especially if you set up like a window beforehand. So that's what I want to do. So first thing is let's figure out the period because that's real important. So the period, just keep using that formula, 2 pi over k. So 2 pi over, and the k is 1/4. So flip that up. 2 pi times 4 over 1, 8 pi. Good so far? So that's the width of a cycle, right? This particular graph, whatever it is, it'll repeat itself every 8 pi. It'll just keep repeating its cycle. Not going to be multiple choice on the final exam. This stuff will be on the final. So I won't even really look close at those. It'll just be, hey, here's an axis, draw me a graph. So, okay. So let's see. So between 0, bless you, between 0 and 8 pi. So that's why I find the period first up. Let me scoot it over so I have a little more room. But just set that up. So first find your period and then set it up, make it a little wider, to cover that. 0 and 8 pi. You can even do another one if you want, whatever. I'm just going to focus on, that didn't look even, did it? I'm just going to do 0 to 8 pi. That's the cosine is going to do his thing, whatever his thing is. Sorry, I just keep changing my mind. Let me come up a little higher. There we go. 0 and 8 pi. All right, he's going to do his cosine thing between 0 and 8 pi. One complete cycle between 0 and 8 pi. That's what it means to say his period is 8 pi. His cycle is 8 pi. Okay. So what is his complete thing? Remember what cosine does in general? He starts high, finishes high. That's one cycle for him. Whereas sine, I know this is not sine, but I just want to make them both clear in your mind. Starts at 0, hits 0 again, and comes back to 0. That's one cycle for sine. Those are both one complete cycle. They just start in different points, and end in different points. So that's the only difference. That makes sense for everybody? The only difference between a sine and a cosine graph is where they start and end. They're the same thing. That's one cycle for cosine, starts high, ends high, looks like a U. One cycle for sine starts in the midline, 0, and ends on the midline. It goes high, goes low, comes back to 0. Right? So know that, right? Know that in your mind. So whenever you're graphing, you think, okay, which one am I doing? Cosine. So basically, I'm going to start high, go low, come back high. Well, I'm sure you'll draw it better than I do. So, right, that's generally it, right? It's a cosine. But there's a couple things I have to change. But so far, so good. That's generally what cosine will do. In his cycle, and we already know his cycle is 0 to 8 pi. Now, what is that? And we've handled that. Don't even worry about that 1/4 x anymore. It's been handled by making the cycle 8 pi. What about that -2 in the front? What's that going to do? The normal cosine goes from -1 to +1, just like sine also goes from -1 to +1. So the normal sine and cosine without anything in the front just goes from -1 to +1. But what does it do when you throw a number in the front? Well, that'll just stretch it, That 2 means it's going to go now from -2 to +2, right? It's going to be twice as tall. And what about the fact that it's negative? What does negative multiplier do in the front of any graph, any function? What does it do to the graph? Flips it vertically. Remember that makes a vertical flip? So it's just going to turn that cosine upside down. So instead of starting high at +2, it'll start here, and it'll do it upside down. Yeah, it's not a very good drawing, but you get what I'm saying. That one's kind of bugging me today. Must be in a perfectionistic mood. So, well, it's worse. All right, whatever. Good enough. So it's upside down here. We good with that? Does that make sense? So we're done. That's the graph right there. That's one cycle of the cosine. It goes from 0 to 8 pi, and it starts at -2, upside down U. Cosine starts high, ends high, or if it's upside down, starts low, ends low. On that. Now, you can take a look at which one of those that is. I don't know which one that is. Oh, is it B? It's got to be B, huh? Yeah, it looks like here it is B. Yep, there it is, B. We good? All right. Okay, try that one. 4 sine of 1/3 x. So go ahead and start by finding the period, right? Start by finding that period. So period will be 2 pi over k. So 2 pi over the 1/3, and then that 1/3 flips up, huh? Times 3 over 1, 6 pi. So the period is 6 pi, so that means from 0 to 6 pi, well, I don't know if there's a dot there, but 0 to 6 pi, he'll do one cycle from 0 to 6 pi. Okay. Okay, then you want to ask yourself, okay, is this sine or cosine? It's sine. So what does sine do as far as his start and his end? Does he start high, end high? No, that's cosine. He starts at 0, ends at 0, huh? Sine does. So he's going to go, and he hits 0 halfway, huh? He's going to go high, hit 0, low, hit 0. Good, that's generally what sine's going to do. Unless he's been flipped upside down. If he has a negative in front, then he'll go low first and then high. Huh? Anyway, what does he have in front? 4. What is that going to do? Well, instead of going up to positive 1, it'll go up to positive 4 and down to negative 4. That's all. Just changes the y-axis, huh? We're done. Does that make sense on that? So say on the exam, I can't remember what I do in the file, but I think I say show me 2 cycles. So if you want to show me 2 cycles, just get the one cycle ready like that, then just repeat it. 0 to 6 pi, one more cycle would be to 12 pi, and it would just go high. There'd be 2 cycles, huh? From 0 to 12 pi. Anyway, which answer is it? Oh yeah, it looks like D, huh? Boom, it finishes by 6 pi. Yep, it's D, huh? Good on that? Does that make sense how to graph sines and cosines? They're pretty straight ahead. If you set up the window, I think it's really easy if you just get the width and the height, and then you know the general idea. Sine starts at 0, ends at 0. Cosine starts high, ends high. Okay. Were they asking domain and range on those?
Yeah. On the past few that you just passed.
Did they just want it for one cycle? What did they want? I didn't answer it here then. Yeah, so on this one, so getting back to, let me answer domain and range. So if this is our 3 sine, so I'll do this one real quick. This is 3 sine of well, here, let's answer the question first, and then I'll do the domain and range. Yeah, first let's graph it. Okay. First let's graph it, then I'll do domain and range. Now, what is that? The only new part is that -1 at the back, right? What is that -1? What does it mean when you add or subtract a number off to the right of a function like that? Remember a long time ago when we were doing graph movements and stuff? You want to ask yourself, is that -1? Is it an x effector? Remember us talking about x effectors, things that have a right and left effect, an x-axis kind of effect, versus y effectors, things that have an up-down kind of effect. How do you know if something's an x action or a y action? Well, if it's in there with the x, oops, scribble in here. If it was 3 sine of x minus 1 like that, then that would be an x effector. But it's not. It's outside of the parentheses, so it's a y effect, isn't it? Because it's not in there with x. Remember that? If it was like this, then it would have a right-left kind of, and it's going to move it. It's going to move it, isn't it? It's not going to stretch it or compress it. That's what multiplying and dividing do, stretch or compress. It's going to slide it either right, left, or up, down. Remember, adding, subtracting moves things. It doesn't stretch them. It moves them. So in our case then, this -1 is going to have a y effect, meaning it's going to move it either up or down. It's going to not stretch it, not compress it, but move it up or down 1 unit, huh? Now, which one is it? Is it going to move it up 1 unit, or is it going to move it down 1 unit? I could see where you might be confused in this way, because I've kind of said a couple of different things at different times. Have you noticed? Right? At one point I said something, and really I'm saying the same story. I'm just giving it to you through different perspectives. Putting them together now, let me make it really clear. Basically, when a number is next to x or y, there's actually not a different rule for x or y. They're the same rule as far as, opposite or same. I'm talking about opposite or same. Remember all those opposite or same talks about, hey, if it's here, it's opposite. If it's there, it's same. If it's x, it's y. Really, let me kind of summarize those all. When a number is next to x or y, it's always opposite. When the number is on the other side of the equals, it's same. Because that changes the sign. Is that making any sense? So in other words, when you look at this -1, which is a y thing, right? Y thing, it's on the other side of the equal sign from the y. So it's not opposite. It's same. Other side. What do I mean same? Same what? What does -1 do then? Up or down? Down. It's going to be down 1. Now, the reason I say that is because you could move the 1 over there by adding 1 to both sides, right? We'd have y plus 1 is 3 sides. That's the same equation. Going to have the same graph. Now the number is right next to the letter, and it's opposite. So it's down 1. The plus 1 actually means down. That's what I'm saying. If it was confusing at different times, it's because they gave us different looks to the equation. But here's what I remember. I just remember this. Remember all the hyperbolas, ellipses, parabolas? We'd always do opposite. Just remember, if the number is right next to the letter, it's always opposite. X or Y, no difference. So I think if you're just real clear on that, that'll help you look at this situation and go, oh, they moved the 1 to the other side, so it's not opposite. It's not next to the Y, so it's same. It's down 1. Down 1. All right. So with all that said, that means we need to take a sine graph, and move it down 1. I would do that right off the bat. That would be the first thing I would do on this one, is go, okay, normally the midline for sine is right here, and for cosine, right? That's the middle of sine and cosine, is the x-axis, normally. But we're going to take the whole sine graph and move it down 1. So just go down to -1. I'm going to put a dotted line just to help me graph it, at down 1. That's the new midline. The whole graph goes down 1. Now, good so far? Do that first. I always like to get the window ready, and then the graph is easy to put in the window once you have the window ready. So the midline moved down 1. Now, how far above and below, how far are we going to rise and fall below the midline? What determines that is the amplitude, which is 3 right there. The amplitude is 3. That's how far you're going to rise above the midline and fall below the midline. 3. So I'm going to take this -1 and I'm going to go up 3. Up 1, 2, 3. Up to +2, And I'm going to go down 3. 1, 2, 3. Down to -4. And I'm going to go ahead and put a dot right there and a dotted line right here at -4. That's the window in which I'm going to fit my sine graph. Does that make sense how we did that? So one more time real quick. Now -1 at the back means down 1 because it's not next to the y, it's the other side. So it's the same. It's down 1. So I made my midline at -1, and then my amplitude was 3, so I went up 3 and down 3 from my -1 midline. So I'm up at +2, down at -4. That's the top and the bottom of this sine graph. The middle's -1, the top is +2, the bottom is -4. Okay, now stick us out. What's the period on this one? Yeah, there's nothing next to x. It's 2 pi over k. K is 1. So it's just 2 pi. Period's just 2 pi, right? There's nothing next to x there. Period's just 2 pi. It'll do its thing between well, I'm going to put it on the midline between 0 and 2 pi. I'll put it on the new midline. Between 0 and 2 pi, well, it doesn't matter where you put it. I guess I better put it on the x-axis. Between 0 and 2 pi, so it's going to start here and here on the midline. Remember, sine starts and ends on his midline, doesn't he? He even hits the midline halfway through. And he rises and falls. That's it. Does that make sense there? So sine starts on his midline, ends on his midline, rises and falls. And I already got his top and his bottom. So that's what you do with that -1 off to the right. It moves the midline down 1, amplitude go up 3, down 3. Put the 3 dotted lines, put the sign in the window. Which answer is that? I can't tell. Whatever. I don't want to waste time. There's no multiple choice on the test. It would just be, give me that graph, and you're good. Questions on that one? Are we good? Oh, yeah. I forgot all about that. Domain range, yeah. So, remember, now this keeps going, right? This keeps going. So what's the domain? Negative infinity, positive infinity. Goes forever, left and right. What's the range? Bottom to top. Bottom is -4. Top is +2. So the range would be -4, 2. The domain, negative infinity, regular infinity. Brackets on the range. Brackets on the range because you exactly hit -4. And you exactly hit +2. Parentheses on the domain because you don't hit the infinities. You just get close to them. Left and right forever. Bottom to top for range. Is that good? Can I keep moving? All right, try that one. So set up the window. Do that +3 first off. Decide what that +3 is going to do. Get your midline, your mid-dotted line, and your top and your bottom on that one before you even worry about the period stuff. So first do that. What's that +3 going to do? Up 3, right? Because it's the same. It's up 3. So the midline then for this one's going to be a +3. And then from that midline, +3, that new midline of +3. How far above that and below that? How far is the graph going to rise and fall above and below the midline? 4. That's the answer. Don't worry about the negative. That just means it's going to go down first, right? But the -4 tells you the amplitude. Positive or negative, it says the same story. It's going to eventually go above and below that midline by 4. So go up 4. To 7, right? Up 4, and go down 4 to -1. Oops. And put your dotted lines. And we've got a window, almost, for our sine graph. Now find the period. Is that okay for them? We've got the bottom, middle, and top. Can you find the period? Two pi over k. 2 pi over what's k? K is pi over 4. So then you flip that up. It's 2 pi times 4 over pi. Pi's cancel. It's 8, huh? We good? So between 0 and 8, not 8 pi, but just 8. Between 0 and 8, but on the midline. So 0 and 8 on the midline. Sine will do his thing, won't he? Between 0 and 8. That making sense so far? He's a sine graph. So what does sine do? He starts on his midline, hits the midline in the middle, rises, falls, but he's got a negative 4, so he's actually going to go down first, then up. There it is. Did I do that too quick? Does that make sense? Questions I can answer? So it's one cycle. Oh, it says show at least 2 cycles, so I'll do one more. Oh, before I do that, are you okay with that cycle? So see how I found the period, 2 pi over k, came out to be 8, and then the midline is at 3, goes above and below that 4, up to 7, down to negative 1. And because it's a negative 4 amplitude, that makes the sine go down first instead of up, right? Sine is the one that starts on his midline, ends on his midline. Cosine is the one that starts high, ends high, like a U shape, right? Everybody with me on that? Right? You want to know the basic difference between a cosine graph and a sine graph, and it's how they start and end. Cosine starts high, ends high like a U. Sine starts middle, ends middle on that, right? They start at different places and end at different places. And so there it is. There's our sine graph, and this one goes down first because it's been turned upside down by the negative 4. Question.
The middle dot, that's like where you're pulling down, and yes,
Here?
Is there a specific point that that's supposed to be on?
Oh yeah, that's halfway.
Okay, so it has to be on 4.
At 4, up 3. Okay. Over 4, up 3. Yeah, exactly. It's right in the middle. And now they want me to do 2 cycles, so I can easily show a second cycle. If this cycle ended at 8, then the next one will go to 16, right? 16. And it'll just do the same thing again. Which means it'll go halfway there, so it'll go low, hit that, go high, hit that. Oops, it kind of came up short. There's my 16. There's 2 cycles. I could keep going, right? Every 8, it'll do a cycle. Backwards and forwards. Questions on that? Feel like you can graph these sines and cosines without too much trouble? That's as hard as you're going to get. Now, we're going to move on. They're going to make us do them backwards. So that's as hard as you're going to get forwards. They're going to give us the so in a minute they're going to give us the picture and ask us for the equation. Go backwards. We good before I flash off of that? They're going to give me a picture and ask me to come up with the equation. All right. So they're giving me an amplitude and a period, and they want me to write an equation. So amplitude is 3, period is pi. Can I write an equation? Well, you know it's generally a sine kx, right? That's the general look of the equation, some kind of amplitude, sine kx. The amplitude is 3, so put that on there. Good so far? Now, how do I find the k? What am I going to do to find that k? What is, remember the formula for period? What's that one? 2 pi over k. Right? And what is the period? They're telling me the period's pi. See how I can now solve that little equation for k? And I'll stick it back in my formula and be done. See what I'm doing there? So period, we just keep, that's like every problem. You're going to use that. Period equals 2 pi over k. All the problems in this section, every time you're doing anything with graphing or the equations, you want to use period equals 2 pi over k. So period pi equals 2 pi over k. Now, how do I solve for k? You can put this over 1 and then just go diagonal, diagonal. You know, just cross multiply. It's about the easiest thing to do. Pi times k is 1 times 2 pi. So pi times k is 2 pi. Divide by pi. K is 2. Bring that back. Put it in. The formula is 3 sine 2x. Oh, so it's right there. Is that good? Working backwards from some information to an equation. A sine kx. All right. All right, we're about done with this section, and then we'll be on to our exam 1 review. In fact, I want to be on there within 5 minutes. So, now these are important though. I really like these. There's no secrets with me, right? There is one of these on the final for sure. I think they're really, really valuable. Is to be given a picture and work backwards from the picture to an equation, because this is what they do in the real world. This is, remember sines and cosines and what they're really used for? Real life engineers, people like engineers, will work on something in the real world, like the alternating current coming out of the wall, or the tides in the ocean out and back, or any kind of motion that is cycled. So all kinds of motions in life and things in life cycle. So what they'll do is they'll, like for the alternating current out of the wall, what engineers do, when I first transferred to Cal Poly, I was computer engineering for that first year, until I realized that my hands were completely useless. That I was good with my head and bad with my hands, and so I said, no more engineering, and I changed to math. I just showed up I transferred as a junior. I went to junior college for 3 years, transferred to Cal Poly as a junior, and so right away I was in those junior level lab engineering classes. I'd done all the calculus and all the math, at junior college, transferred, so I was ready for the labs. I just showed up in a lab. There were these things sitting in our stations, and the lab teacher just went, all right, guys and gals, wire up them breadboards according to that circuit on the thing. And I was like, what's a breadboard? And everybody else was just going. They were like, no problem. Like, they'd done this all their life. They'd all grown up, I guess, doing that kind of stuff. I hadn't done any of that. I just knew math. I didn't know anything practical. So anyway, I had all kinds of troubles in the actual practical. My wires wouldn't touch. I'd work it all out mathematically, no problem. Oh yeah, this circuit needs to do this, and the little thing will do that. I'd have it perfect math. And then I'd try to actually do it, and some dumb little thing would happen. Like 2 of my little wires, I didn't make them touch strong enough. That stuff drove me nuts. I'm not a hands person. You kind of learn who you are. I did. I learned at that point. I'm terrible with my hands. I do stupid things. I do dumb little. I just don't think. I don't have good common sense with my hands. I just don't have it. I just do the dumbest things. And people would come by and go, "Why do you do that? Don't you know the wires don't touch good if you don't do it?" I'm like, no, I don't know that. How do you know that? Well, they just grew up doing it, and I didn't. Anyway, so I changed the math. I realized that part of that. But for a little while there, I used the oscope, the oscillator, and so we would take a picture of a circuit or something, some kind of current thing, and we'd get a little graph. That's what engineers really do. That's one of the things that electrical engineers do, is they'll get a little picture on, you just hook it up to the whatever you're working on, and it'll show you the little graph of what's happening. And so your job then is to turn that into an equation. So you can use it to do all kinds of other things, to predict, to hook up with some other power supply, or to do whatever, trying to run something in the real world. So how do you do this? This is very, very practical. How do you take a picture from some instrument, like an oscillator, that's telling you this is what that thing out of the wall is doing, and write an equation that you can then use to do other things with? How can you go from picture to equation? That's really the real life direction things go. So how do you do that? Well, first off, let's look. The easiest way to do this is to look at where it starts. And by starts, I mean I always go to x equals 0. And where one cycle, because they're going to give me way more. The oscilloscope gives you tons of cycles. You just want to grab one cycle. So it starts here and it ends there, its first cycle, doesn't it? Everybody good with that first off? So you just start at x equals 0. And then go till one cycle is done. And I won't even care about anything else. I'm just going to focus on that. Starts here, ends here, one cycle. And what is this? This is 0 here. And what's that, 3? Yeah, it looks like 3. It's just 1, 2, 3, huh? So it does one cycle between 0 and 3. So the period, which is 2 pi over k, we always use that formula, period is 3, isn't it? We good to there? The period is 3. 1 cycle, 0 to 3. Okay, so how do we solve that for x, for the k now? Put this over 1, diagonal, diagonal. 3k is 1 times 2 pi. 3k is 2 pi. Solve for k, divide by k is 2 pi over 3. Okay, now you know the formula here, right? They said you could do sine or cosine. Oh yeah, some of them are. Is this one going to more naturally? Really, you could do either one technically, but it's going to be way easier. It's going to fit much better, more easily made to fit with one of them than the other. This one, think about how he starts and how he ends. He's naturally sine. You could of course do cosine shifted, but that's a pain. We don't want to do that. This one starts on 0, ends on 0. Remember, cosine starts high, ends high. This one starts 0, ends 0. Sine is the natural fit. Now, when I say start, you might say, no, Mr. Aaron, it starts way over here, or it starts up there. I mean when x is 0. When I say start, where is it at x is 0? It's right here. Because I know it goes forever left, forever right. But I'm saying at x is 0, where is it? I'm calling that start. It's at 0. So sine is the natural fit. A sine kx. What's the amplitude? It's going up to 10. But yeah, it goes down first. Sine normally goes up first. So that's a negative 10 for the A, huh? Everybody see that? Sine and the k we just found, 2 pi over 3. 2 pi over 3x. There it is. That would be the equation that would produce that graph. Very important, very useful. That's what engineers do, is things. That's the part of engineering I liked. I liked that part. I could do the head stuff. I just couldn't make anything actually physically happen. All right. Is that good? Does that make sense? Questions on that? So we did that? All right, let's try another. This is very important. But this matters. This is on the final. Let's try this and one other one, maybe. All right, so try that one. Really important. A lot of people miss this. I mean, the majority. The majority of the class on the final usually misses this. So I'm trying to do all I can. No secrets. It's on the final. I'll put a graph and I'll say, give me the equation. Don't worry about all that multiple choice stuff. I'm not going to give you multiple choice. I'll just give you a part of a graph like that. I'll say, what's the equation of that thing? So do the start and the end of one cycle. One cycle. So starts here, ends here. That's one cycle, right? Between 0 and 1. One cycle. So the period, which is 2 pi over k. The period is 1, isn't it? Everybody see that? It does one cycle between 0 and 1. The period is 1. So I got to solve for k. Put this over 1, diagonal, diagonal. 1 times k is 1 times 2 pi, meaning k is 2 pi. Good. Now, is this naturally going to fit as a sine graph or a cosine graph? Sine, because it starts on 0, ends on 0. It doesn't start high, end high, like cosine. Starts at 0, ends at 0. So I'm going to use a sine kx. I've got the k is 2 pi. Okay. What's the a? 5 over 6. Is it negative or positive 5 over 6? Positive because it goes up first. And we got it. Does that make sense? Feel like you could do that? I always think everybody should get it on the final. Then I'm grading the final. I'm like, oh, they're missing it. Why is usually about half or 60% missing?
So like you're going to give us a graph and make us do the equation? Is that what you're saying?
Yeah, exactly like this. I'll give you a graph and say, give me the equation. Just exactly like this. Yeah, it's on the final. And you get a full sheet of paper. You write this whole example on. For the final, you get a full sheet of notes. Both sides. You can write this example in there. I always think I'm doing all I can do. All right. And then we better get on to review. Yeah, this will have to be our last one. All right, try that one. That one's a little more tricky. You see why it's tricky? The midline's been moved, huh? It's been moved vertically, right? So I would put in his new midline. You really need to see the midline. I do anyway. It helps me to see that midline. You know? So just, I would put on the midline and then think about it that way. So the midline, where is it? Right there. Right, always. And how high is that midline? That's at 1, isn't it? Because this is 2, so this is 1. Up 1, as the midline looks like. We good? So then put your dots where it starts and ends one cycle. It starts here. Now, is it starting on its midline? So be careful. Careful not to be, it's real easy to get confused here to think, wait a minute, Sharon, you said sine starts at 0, ends at 0. Well, yeah, it starts on its midline, which is normally 0. Right? So be clear on that. Sine, this is a cosine, in other words, not a sine. Is everybody seeing that? Because this one doesn't start on his midline, right? Cosine starts and ends high, or low if he's upside down. Sine starts and ends on his midline. But this his midline's been moved. So is this dot starting on the midline? No. So it's not sine, huh? It's cosine. It's upside down cosine. It's starting at its lowest point, isn't it? It's not starting on its midpoint, right? Sine starts at mid-level, then goes higher than that, then goes lower than that, and comes back to mid. Cosine starts at his very highest and ends at his very highest, or if he's upside down, his very lowest. So this is upside down cosine, and there's one cycle, huh? Everybody good with that? Everybody seeing that? This fools a lot of people, so I want to do whatever I can to help. Everybody seeing that? So this is cosine. This is upside down cosine, isn't it? So it's a cos kx, right? And I always start at x is 0 here. So this dot here. You might go, yeah, but over here, remember, I started x equals 0. If you started somewhere else, you'd have to put what's called a phase shift on. I just don't want to go there. It's more complex. This is way easier. Start at x equals 0. So start at x equals 0. He's starting low. So his a, what's his a then? What's his amplitude? How far above and below the midline does he go? Only 1. So it's -1 cosine kx. So far, so good. Now we just got to find the k. Because he goes down first, 1 unit. How do you find the k? Period, as you know, is 2 pi over k. What's the period? 1/4 is 2 pi over k, diagonal. 1 times k is 4 times 2 pi. So k is 8 pi. So there it is. It's -1 cosine 8 pi, not k, 8 pi x. There it is. We got it. Oh yeah. +1. Because it's been moved up 1, huh? Up 1? Yeah, the midline has been moved up 1. Thanks, I forgot that +1 in the back. Yeah. That good? Questions on that one? That's absolutely as hard as it gets. Right there. No questions? Let's go. All right. There's never all the time we want. So here we go. Part 2. Theater has 20 rows with 28 students in the first, 33 in the second. Look at all those formulas. I'm going to give you all those formulas right at the top, exactly like that, of your exam. This one we never used in this class. It's a different way. You can do some other different thing. I didn't talk about it, so you won't need it. Everything, you can do everything that'll be on there with those other formulas. All right, try that first one, number 1. All right, which formula are we supposed to do? So let me be clear here. So it's 28 seats in the first row. Add 33 in the second row. Add 38, and on you go. 20 rows. So we good so far? That's what they're talking about, huh? They want me to find total seats in the theater, which means add up 28 in the first row, then 33, then 38, etc. 20 rows altogether. Okay. So, which formula are we going to use to make that happen? Let me show you up top how these go. These first two are the arithmetic formulas. These two, a sub n and s sub n. These last three are all the geometric formulas, a sub n, s sub n again, and an s sub infinity. Right? So we have two a sub n's, one for arithmetic, one for geometric. We have two s sub n's, one for arithmetic, one for geometric, and then the s sub infinity for geometric. Okay, so is this an arithmetic or a geometric series? Yeah, how do you know whether it's arithmetic or geometric? Arithmetic would mean add or subtract same number each time. Geometric means multiply or divide the same number each time, remember? And a sub n are formulas are when there's commas between. S sub n formulas are when there's plus signs between entries. So I'm trying to give you the rules to distinguish whether something's arithmetic or geometric, and whether you should use a sub n or s sub n formula for arithmetic or geometric. That'll distinguish the four cases. So as you look at this, you say, okay, look, we're adding 5 every time. So it's arithmetic, right? It's arithmetic. First thing you learned when you started as a kid in math, right? Adding, subtracting, arithmetic. We're adding the same number of times. So it's an arithmetic situation. Now, how do I know if it's the a sub n formula that I mainly want? We might use both. We will use both on this one. But what's the main one? What's the one from which my final answer is going to come? A sub n or s sub n? Well, the way you tell is a sub n is when there's commas between them. S stands for sum. Plus signs, adding them up. So what do we have? Plus signs. So it's the s sub n mainly. So n over 2, a1 plus an. Good there? See how we figured out which one? So that's why it's so important to do the practice then, because when I did lecture, it might have made sense to you during lecture, but I was just doing one thing at a time, huh? I was just doing arithmetic that whole day or 2 days. So it's different on a test because there's one of these, one of those back and forth. You got to know it better. So practice on the practice exam. Use that, and even if you really want to do well, go back and do more homework and mix it up, practice it up. All right, so here we go. What's the n always stand for? Number of terms, remember that? A sub 1 is always the last term. So number of terms is n, first term, last term. Okay, here we go. What's the number of terms? Do we know the number of terms? 20, yeah, that's the number of rows, right? There's 20 rows. Right? Every row is a certain number of seats, right? So there's 20 terms in that list, huh? One for each row. Okay, first term, a sub 1, so n is 20. First term is 28. Good so far. What's the last term? I don't know. It's somewhere back here and I don't have it. So I've got to use, I got to find a sub n. So now I'm going to use the other formula, the a sub n, because it's a sub n, I don't know. Huh. So what is a sub n? Grab it up here. It's a1 plus n minus 1d. So it's a1, first term again, 28, plus n minus 1. N is still 20. D, what's D stand for? The 5. It's the difference, it's the jump from term to term. It's 5. So that's 28 plus 19 times 5. 28 plus 50, 45 plus 95. It's like 123. So a sub n's 123. Now I bring that back to the S sub n formula. The S sub n is the main one from which my answer will come, right? So this is 10 times 151. It's 1510. There we go. 1,510 seats in that theater. That's what they all add up to be. This would be how they really do this, because nobody wants to count them all by hand, one at a time, right? 1,510. They use formulas. Questions on that one? Is that okay? Had to use both. All right, how about you start number 2? I want to leave this up for just a second. Well, I can't even see number 2 now, huh? It's all scribbled all over.
Story of your life.
Yeah. Too much writing. All right. Everybody got this down? I better go to a fresh screen. We got this down, okay? 1510, total number of terms. All right. I'm going to move on. If you didn't get it, it'll be on the YouTube right after class. Number 2, 42nd term of this. So figure out which formula to use. Is it arithmetic or, well, it says arithmetic, so it's arithmetic. So do I want there's 2 arithmetic formulas. There's an A sub n and an S sub n. So that is determined by, is it a sum? Are there plus signs between them? If so, we'll use the S sub n formula. Is it a sum, or is it just listing them with commas? Clearly commas. So it's the A sub n formula, isn't it? I'm not going to use the S sub n on this one, right? Commas, not plus signs. So A sub n, not S sub n. It's not a sum. It's just a listing. Good? So A1's the first term, which is -5. N is always the number of terms. What's the number of terms?
42.
Yeah, remember I said it's the ordinal, like 42nd. It tells the order. It doesn't just say 42. It says 42nd. That's an ordinal, kind of implies an ordering, right? That's always N. N's are always your ordinals. So that's the 42, right? Because in the end, we'll have 42 numbers. They want me to find the 42nd. The D, what's the D? The difference from term to term? It's going down by 4 every time, huh? It's multiplied by -4. So there it is. -5 plus 41 times -4. -5 minus 164. Minus 169. Kind of scribbling those 6's out there. Minus 169 must be the 42nd term. All is well? Try that number 3. I'll do it in a fresh screen in a minute, but you can still see it in your screen. Perimeter, parking lot's 500 yards, find dimensions of the lot. Length is 50 yards more than 3 times the width. They should have said it's a rectangle. That's kind of a bad question. Yeah.
Just one.
Oh,
The middle
just this sum of k squared. Yeah, we won't use that one. We could have done some of the problems using it a different way, but I didn't do it that way, so we won't need it. So try that number 3. It's a rectangle. So draw a rectangle if that helps you, or just think about the formulas for a rectangle. Perimeter. So you need to know the perimeter, or put on your 3x5 card, perimeter of a rectangle formula. All right, so perimeter. So okay, so for a rectangle, does anybody remember the perimeter formula? Perimeter of a rectangle. 2 lengths plus 2 widths. Yeah, it's got a width and a width and a length and a length. And perimeter just means going all the way around the object, huh? 2 widths and 2 lengths. Add it up. Okay, good. And it says the perimeter is 500. So 500 is 2L plus 2W. Good so far? Now that's 2 letters. Whenever you have 2 letters, you need 2 equations, right? If you just have 1 letter, you only need 1 equation. So I need a second equation, and that's over here. And see if you can take it straight as an arrow. Length is, what is is always? Equals, right? If Johnny is 10 years old, his age equals 10, right? Is means equals. Length is equals 50 more, what's that? 50 added to something, right? 50 more. If you have 50 more, you add 50, right? 50 more than what? 3W. So we just took that real straight. Length equals 50 plus, 50 more than 3W. Okay, so there's my 2 equations with 2 letters. How do I solve? What am I going to do?
Plug in.
Yeah, real nice to plug in, huh? Super ready for plug-in. So just L is 50 plus 3W. Plug that in for L right there, huh? So we get 500 is 2. And we'll plug in for the L 50 plus 3W. That makes sense? And then I'm just going to whip it out because I won't got bigger things to do than this. It's 2W. 500 is 100 plus 8W. Subtract 100. 400 is 8W. Divide by 8. What's that, 50? So W is 50. Bring it up and plug it in. Plug in W. W50 where? I'll just grab, it'd be easiest actually to grab the L equation because you want L, L's already alone here. You could do either one, this one would be easier. Plug in the 50, L is 50 plus 3 times 50. L is 50 plus 150. L is 200. Length is 200, width is 50. Good there? So 2 equations, 2 letters. We're going to have one of those on the test because that was section, I think it was 11.1. It's like the oldest thing on this test. It's the first thing we did right after exam 3. That's the furthest back. I'd kind of forgotten we did it. 2 equations in this section of the course. 2 equations, 2 letters. All right. Well, I'm going to move.
On the perimeter question, are you going to ask us for each side of it, or you're just going to ask us for L and W?
Yeah, just L and W. So, yeah.
So it's not going to matter. Like, would this mean that this is like 25, 25?
Oh, no, they're both 50.
Both of them
50, 50. What's right here? 50, 50. And 200, 200. And what if you add all those up? What would you get?
Yeah. Okay. Okay, that makes sense.
It would make the total.
I see.
Yeah.
Okay.
Yeah, but they're both width and they're both length. Yeah. All right, so try number 4 there with the recursive. See what you remember. It's all about reading this. Is that speaking a language that's comfortable to you or not? I think, let me give you 30 seconds. And then I'll help it make sense if it doesn't already. They just want 4 terms. They just want A1, A2, A3, A4. So, and A1's already there. It's 2. They just want the other 3 terms. So, okay, what is this thing saying? This is saying any term, A sub n is any term, is 3 times the previous. Add 4. Do you realize that's what that's saying? Any term is 3 times previous. A sub n minus 1, that means previous. N minus 1 is 1 back. So I think if you think that way, I think you'll just snap it out real easy. You know, because the first term is 2. They've already given us that. So the first term is 2, and then any other term, you just take, so like for a sub 2, for example, you just take 3 times the previous, 3 times 2, add 4. What's that, 10? And then for a sub 3, you just take 3 times the previous, add 4. 3 times the previous, add 4. See what I'm doing there? It's always, it just says any term, a sub n, any term, is 3 times the previous, add 4. So it's all about kind of making sense out of that statement. Does that make sense there? 3 times the previous, add 4. So here's the first one. 3 times the previous, add 4. 3 times the 10, the previous is 10 now. Add 4, what's that, 34. So that's the third term. And then the fourth term is 3 times the previous, 3 times that 34. Add 4, that's something big, 90, 106, thank you. So there's the first 4 terms, that's what they want. We're done. Is that okay? Okay, so number 5. I would just put this in my calculator. Totally. Just remember, you'll have your graphing calculator for all this stuff, right? So just put it in your graphing calculator. Just remember how to do that? Put in matrix, hit second, matrix, and then go over to the edit, twice to the edit menu, hit enter, and then put in the matrix, the 5, 3, 3, 2, then hit second, quit. So step 1, do that. Step 2, second, quit, and then hit second, and third, hit second, matrix, and you're on names. Under the names menu, which you're already under, just hit enter, and then matrix A will pop on the main screen, and then hit, what is it? Is there X to the minus 1 button or something? Is that what it is? That has the matrix word above it, I think, right? On the TIs anyway. Hit X to the minus 1 button, hit enter, and it'll do it. And the answer ends up being, the final answer, I just did it last hour, so I know it. It's that, huh? Which you could also do it by hand. I don't want to take time. If you're interested in doing it by hand, grab me after. I'll be glad to show you, but I want to keep moving. So just put it in your calculator. I would just put it in my calculator, hit the inverse button, it'll do it. I would do that for all the matrix stuff. Just put them in your calculator. If you have any trouble, come see me, Roberto. Be glad to help. Good with that. Got that answer. Want to try number 6? Go. I'll leave this up so you can start on number 6 now. Try number 6. We did a few of these. Remember, these are the ones where we're going to use the a sub n formula. It says arithmetic, so we know it's not geometric. It's arithmetic on number 6. And how do I know it's the a sub n arithmetic instead of the s sub n? Well, because we're not adding anything. There's no sign of summing up anything. It's not s sub n. It's a sub n. So on number 6 here, we're going to use a sub n is a1 plus n minus 1d. Remember how that works? And you plug in the 2 pieces of information twice, and you get 2 equations, 2 unknowns. Remember those kind? You solve them. You run a negative sign through one of them, and then add them up, and the a1s drop out. Remember that whole thing? I'll do it in a second. Just let everybody copy down the matrix instructions. But for those of you already moving ahead, do that. Use that formula, plug it twice. Which formula are we going to use on this one? Is it arithmetic or geometric? How do we know? We got to get, well, yeah, there's 2 ways. Yeah. If it's exponential, and by that I don't want to just use math lingo that you should understand, the letter in the power zone. That's what exponential means. The letters in the power zone is geometric. Geometric. If it's linear, which you know what that means, right? Like mx plus b then it's arithmetic. Yeah, so what's this one? That k's up in the power zone, right? That's k minus 1 up in the power zone. So this one is geometric. So remember that when the letter gets in the power zone, it's geometric. So this is geometric. That's how you can tell whether it's arithmetic or geometric. The letters up in the power zone. Okay, so we know it's geometric. There are 3 geometric formulas. We had a sub n, s sub n, and even the infinity one. This is not infinity. But how do we know whether it's a sub n or s sub n for the geometric? Yeah, because this is a big Greek. That's a Greek s, basically, right? So it's the s sub n. It's the geometric s sub n. Does everybody see how I figured out which formula to use there? Again, we knew it was geometric because it's exponential. The letter k minus 1, the k, is up in the power zone. So if it's linear, that'd be arithmetic. If it's exponential, it's geometric. And then the Greek s, sum. So s sub n is a1, 1 minus r to the n over 1 minus r. That's on the top of the first page. Don't even need to put it on your 3x5 card. It'll be there on the test for you on the top of the first page. So there's our formula. Plug in what you can. See if you can find A1 and R. What are you going to have to do to find A1 and R? You're going to have to get the first 2 terms, huh? Right? Just by taking that formula and plugging in k as 1 would be the first term. And plugging in k as 2, and that'll get you the second term. So I take the formula, plug in k as 1 to the 1/4 times minus 3 to the k minus 1, and then I'll plug in k as 2 to the same formula. So plug in k as 1, you get minus 1/4 minus 3 to the 0, huh? And plug in k as 2, and it's the 1 power, and so this is just 1/4 times 1, which is 1/4, and this is 1/4 times minus 3. What's that?
Wouldn't you do the first and the 13th since you're trying to find the sum of them?
For the arithmetic formula, we need the first and the last. Right? Remember that as a1 is n over 2 times a1 plus an. You need the last, so we would. If this was arithmetic, yes, good question. If this was arithmetic, that's where I had to find the first and the last. But for the geometric, notice it never has the a sub n in there. It never has the last, so don't need it. All we need is the a1, the r, and the n. So, all right, so this is the a1, right, first term. So we can put that in there. First term's a 4th. And now what's the r? How do we find the r? We can't subtract. Subtract's for arithmetic, right? Because that's D for difference. In the arithmetic form, you have a D, which means difference, which means subtract. Second term minus first. But for geometric, you got to take a ratio. It's R, second term over, ratio over first term. So that's second term over first term. So minus 3/4 over 1/4. So that makes sense? So this takes practice, doesn't it? Because we did certain stuff for arithmetic, different things for geometric, similar but different. So you got to spend some time practicing to get all that straight. So what is that? Minus 3/4 times 4 over 1. 4's cancel. Minus 3. R's minus 3. So bring that on back. R now is known to be minus 3. Watch the subtraction symbols, right? What's the n power? N is 13. It's the number of terms. There must be 13 terms if we're going from 1 to 13. All right, that was a lot of work. I plugged all that in there. Watch out for the double negative thing, right? We have the subtraction from the formula, and then R itself was negative. Okay. Maybe I'll come up here. Okay. So coming up here, so we have, this is it. So it's 1/4 times 1 minus minus 3 to the 13th over 1 minus minus 3. Okay. So it's S sub n is 1/4 times. Now, the double negative is positive top and bottom, right? Careful, though. That's right. What I just wrote is right. But it's, bless you. It's not. If this had been, remember, you got to do the power first, right? So you can't say, well, these two minuses make a plus. Not first. First, the power does his thing, and then the minuses, if they're still left, will multiply, right? Multiplying comes after powers. Remember, please excuse my dear Aunt Sally PEMDAS, right? Exponents are before multiplying. So this power must be done first. But I know a 13th power on a minus sign will leave it minus. So that minus will stay, will hit the other minus eventually, and it will become plus. But if this had been like a 12th power, then that would not be the case, right? Because the 12th power on the minus 3 would have left the minus, it would have made the minus 3 positive, and the other minus in the middle then would have just sat there alone and still been there. Does that make sense? For an even power, it would have made the thing in parentheses positive, wouldn't it? But because we have an odd power, 13th power, the thing in the negative in the parentheses stays negative, does hit the other negative, the two negatives become positive, and certainly that happens on the bottom because there's no powers at all. So what do we get? Can I just go 1/16 on the bottom? Right? This is 4 times 4 on the bottom, 1/16 times 1 plus 3 to the 13th. Hit the buttons on your calculator. Get the answer at that point, right? Good there. Or you could learn how to do this whole thing right on your calculator, but you still got to show me the formula at least to that point. And then you can just write the final answer. That's fine with me. Makes sense? Questions? Can I move on from that? That would take a lot of our time. 10 minutes or so. Let's get as much as we can done here. All right, solve the system of equations by hand. Show your work. No. That's back when I was a mean teacher. Now I've become much nicer, softer, I guess, in my olden age. I just think, why do we need to do all that tedious work? So, graphing, calculator's okay. So, just put this thing into your graphing calculator. Remember, you put the coefficients, 1, 1, 1, and even the things on the right side of the equal sign, the answer is -8. And then 1, -1, what's that, 4, 5, and then 2, 1, 1, -12. Just type that into your calculator, right? Put that in matrix A, like I wrote up last time, right? And then you got that step 1. Put that in matrix A. Step 2, hit second, not calc, second matrix. Hit second matrix. Go across to the math menu. Go down to RREF. Remember that? RREF. Hit enter. Enter. Why that E didn't work there. Enter. And then on the main screen you'll have RREF. And then go back into second matrix again. You'll be under names automatically. Hit enter once and actually enter a second time, and it'll do it, and you'll get your final answers. Here's what the answer will look like. When you do that, your final answer will have ones down the diagonal, which you can ignore, and then the answer on the right side. Has anybody got it? What's the answer on the right side? -4, -5, 1. Thank you. That's what I remember from last hour, so that must be right. So this is our answer. This is X, Y, and Z. We're done. Make sense on that? So if you have any trouble with that, grab me after class. Today I get a couple minutes, and or grab Roberto or my office hours tomorrow morning, 9 o'clock. 9 to 9:50 I'll be there. Go to the tutoring center. Make sure you can do that on your graphing calculator. Number 9. Determine whether the infinite, it even says infinite geometric. So I'm going to clearly use the S sub infinity formula, which is A1 over 1 minus R. That's at the top of your page 1. It's up there. S sub infinity. It says infinite. You see the dot, 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 so we know we're grabbing the infinite. A1 over 1 minus r. So what's A1? A1's first term, 32. What's R? R is always second term over first. 8 over 32. 0.25 or 1/4, either one. 0.25 is fine. So that's my R. 0.25. So it's 32 over 0.75. Hit the buttons on your calculator. Some kind of decimal, whatever it is. Does that make sense on that one? Now, actually, technically, careful. We had to make sure, put this out of the way here, that the R had to be between -1 and +1. It was 0.25, so it was. So it's okay to use the formula. It's okay to use the formula. If R, I'll come up here. If R is not, let's space that out a little bit. If R is not between -1 and +1, what do you say if R is not between -1 and +1? Diverges, which means it doesn't ever come to one fixed number. There's no answer. So you have to check that. Remember when we use that S sub infinity formula, the A1 over 1 minus R? You do have to check your R. If it's a fraction, a decimal fraction, same thing. It's a decimal or fraction between -1 and +1, right? Then it's okay to use the formula. And 0.25 is between -1. A quarter is between -$1 and $1, right? So it's okay. But if R is not between -1 and +1, then you can't use the formula. You just say diverges. No answer. Good, remember that? All right. Okay. Look at number 10 there. 10 is a sum formula, so it's certainly S sub n, right? The Greek S. The Greek S always leads to the English S, the S sub n. But which one? We have an arithmetic S sub n. We have a geometric S sub n. How do you know which one that is? Yeah, n is not in power, right? This is linear, right? It's like mx plus b kind of thing, right? Except it's an n, mn plus b, you know, whatever. So it's arithmetic. Arithmetic. So that's n over 2 a1 plus an. Those are long stem days there. a1 plus an. So there it is. So we got to find n. What's n? N is number of terms. And then first term, last term. What's the number of terms? 32. First term. How am I going to find the first term and the last term? Yeah, let n be 1. And a sub n last term, let n be 32. Because remember, there's 32. So here's the one we were talking about earlier. We've got to find the first and the last. So this is where we got to do it. So plug in 1 to the minus 2n plus 8 formula. Plug in a 1. And then plug in a 32. That way you'll find the first term and the last term. Minus 2 times 1 plus 8 is what, 6? And minus 2 times 32 plus 8 is minus 56, I think? Yes. Thank you. So 6 plus negative 56. First term plus last term. First term, last term. And so this is 16 times minus 50. Is that like minus 800? Minus 800. And again, if you learned how to do it on your calculator, you could just hit the buttons. Good to there? This one's going to be exactly the same. Can I just go same as number 10? It's funny I gave two of them that are the same thing, really. Same as number 10. It's a funny looking 50. I scribbled. We good? Number 11 is just use the calculator, right? 10, 3, negative 4, 15, 9, minus 7, 7, minus 3, 3, 4, so minus 1, 12, R, R, E, F on your graphing calculator. Reduced row echelon form. And boom, right? Just like, what was the other one, number 9? 8?
8.
Yeah, just like one of those for that. That good there. How are we doing? Are we almost done?
No, it goes to 20.
20?
Yeah.
Was it really?
Yeah. I have it right here.
Oh, man. Everybody got that copy down? That okay? Let me glance if there's anything important to say there. So, let me see.
I mean, you do have the work on there.
Okay, so, yeah, this is, you know it says by hand? No, I don't care about that. Just by calculator is okay. So just use your graphing calculator on 13, 14. Just put them in your graphing calculator and crank them out. 15, determine whether the given sequence is arithmetic geometry. How do you look at this? You know, it's adds 2, adds 3, adds 4. It's adding a different number every time, huh? It's not adding the same number every time.
Surveys?
For
ETC.
For m4b?
Mm-hmm.
Oh, we actually get out at this time. I'm sorry. I know. Okay. I communicated with Heather, and I told her come anytime. Right. What I didn't tell her is we take no break and end 10 minutes early, so we're done at this point. Okay. I'm sorry.
Next week, Tuesday?
It would be great. Next week, Tuesday, would be great.
Thank you.
Anytime other than the last 10. Okay. Sorry. Tell Heather I'm sorry.
Okay.
Okay. Yeah. So this is neither because it's not adding the same number every time. It's not multiplying the same number every time. Find the fifth term of that. Is that tricky? You'd use it's geometric. Geometric. So it's what is it? I can't remember what's that formula. It's A1 times R to the n minus 1, right? So there it is. So what does that mean? Well, they're saying the fourth term, plug in a 4, is the first term times R, negative 3, to the n minus 1, plug in 4, right? So I plugged in 4 for n here and here. And the a sub 4 is negative 54, equals a1 minus 3 to the third. So you can just solve that for a1. What do they want? Oh, it says wants the fifth term and the nth term. Okay. So they're not being easy on this one. So minus 54 is a1 times minus 27, minus 3 to the third. Divide by minus 27. What's that, 2? So a1's 2. So now I can say, okay, so the general formula an is a1 r to the n minus 1. Now I know a1 is 2. 2 r to the n minus 1. That's the general nth formula. Oh, what was r? R was negative 3. We'll put that in there. So there's the nth formula, and you could find the fifth easy. Just plug in a 5 now, right? You could find the fifth. Good. And then what? 17, find the nth term. Same thing. It's the nth term for the geometric. 18 and 19, or 19 and 20 were binomial. We just did binomial, so you need to review binomial. What was 18? Was 18 something? 18. Oh, yeah, those are hard. We don't have time for that. Those are that. 8. Yeah, sorry. 18 is where you have two equations, and you got to plug one into the other. Substitution method, a lot of work and all that. Those see the answer key. Those are long. 19 and 20 are binomial theorem. See the answer key. All right, guys. That's all we got time for. Practice those. I'll see you Thursday. Roberto's available.
At least a C.